Hello, everyone. It's April 23rd. All right, let's get on to it. Actually, I have nothing to report today. I watched a lot of weightlifting today, so kind of give myself a little break. Anyway, let's get to it. Count binary substrings. Given a string S, count the number of non-empty, which means continuous substrings that have the same number of zeros and ones, and all the zeros and ones in these substrings are grouped consecutively. I don't understand this. Substrings occur multiple times. I counted the number of times they occur. All right, let's see. There are 6 substrings that have equal number of consecutive ones. Equal number of consecutive ones and zeros. 0, 0, 1, 1. 0, 1, 1, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1. So 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1. Count the number of non-empty substrings that have the same number of zeros and ones, and all the zeros and all the ones in these substrings are grouped consecutively. Okay. The sum of the substring repeats and uncounted the number of times they occur, so we count the repeats. Also, 0011, 0011 is not a valid substring because all the zeros and ones are not grouped together. Okay, so this won't be, let me write it out, see if I understand this question correctly. So we have 1, 0, 0, 1, 1, 0, and 0, 1. Yeah, 1, 0, 0, 1, 1, 0, 0. Okay. 50,000. Ooh. Oh, when? We'll have a hint, which we'll use if we cannot figure this one out. All right, so it has to be, let's use the first example. It has to be consecutive. Okay, so the same number of zeros and the same number of ones, and they have to be consecutive. So we read from the start, right? We have 0, 0, so we have 2 zeros, which means we have 1, 0, so we need to find a 1, but the next one is not a 1, that's a 0, so now we know we need 2 ones. But now we have a new 0, have a new start, which means I only need 1 ones. So we'll have a 0, 1, that's 1. But we also have a 2 zeros, so we need to fit. And so we have 1, 1, that's 2 zeros. But now we have ones, right? We're on 1 territory, so we need to get another 1, so we need to get 2 ones. It's like rolling, the thing is keep rolling. So we have positions, right? So at the first position, we have a 0, and we need 1, 1, right? And the second position, now the first position will get updated to 2 ones. The second position will have 1, 1. And then we hit a 1, which is the third position. And then that's a 1, so we go look for, so every time, hold on. What is the logic in this? Substring. Zero, 0, 1, and then we find a 1. We find a 0, we try to look back. Like, I find a 1, the first 1 we find, try to look back, and that's a 0, then that's 1. And I find the next 0, a next 1, so we have 2 consecutive 1s. So we can count consecutives, right? That's what we can count. So we can count, we have 2 consecutive zeros so far. And then we have a 1. Because we know we have 2 consecutive zeros, so that's a 1. And we have 2 consecutive 1s, that means that's another 1. And then now we have a 0, so we need to know how many consecutive 1s we have. We have 2, so that's a 1. And 2 zeros, that's another 1. And okay, so consecutive, we count the number of consecutive zeros. And when we hit 1, we count consecutive 1s. And based on the number of consecutive 1s and the consecutive zeros we have, we can count how many we have. So we have 2 consecutive 1s and 2 consecutive zeros. So that's give us 2, right? Basically, we can have the smaller. Like if we have 0, 0, 0, like 3 zeros, like if we have 0, 0, 0 and 1, 1, we're gonna have 2. The smaller of the 2, right? And if we have tons of 1s, that's also the smaller of the 2. So that can be 3. So basically, I think we just need to count the consecutive 0 and 1s as we go through. And every time we hit a new, like we have consecutive zeros or consecutive 1s, we have a new one, and we count it, then the answer will be the smaller of the 2. And then we count the next one, and then, okay, if this one works, so that will be 1, right? And then we count this one will be 1, this one will be 1, this one will be 1. So I kind of have an idea. Let's see if this one works. In my mind right now, I don't have a very, how should I put it? I don't have a very elegant way of coding, but I think the basic idea shall be correct. Basically, we're just trying to count how many consecutive zeros and ones we have, right? So what we're gonna do is we're gonna copy this one here, right? And then consecutive 0 and then consecutive 1, right? And then we're gonna say for lettering S, right? If letter equals 0, then consecutive 0, oh, not this one, plus equal 1, right? And after we do that, we also want to know, actually, every time we hit it, we just try to check the previous one. And then, yeah, so we hit it, right? And then we see the previous. We say the result. We're going to have a result as well. And we can put a result here. So every time we have a consecutive, then result can just plus equal to min consecutive 0 and consecutive 1, right? So for 0, 0, that would be 2, but that's 0, so that's 0. And let's say Aleph, letter is 1. Oh, we also need to know whether we need to reset. I mean, let's write this logic first, right? And then this one's the same. Now, after we count, like after we hit a 0, we need to check if the 1s are not 0, right? That means that's a new start. Hold on. So 0, we count 0 is 2, right? And then we count 1s. And then we hit 0 again. So it should be when we hit 0, right? When we hit 0, if the 0 count is not 0, then we need to set it to 0 because that's when we start. Yeah, so it'd be like this and say if not consecutive 0, then we set consecutive 0 to 0, right? And then we're gonna do the same thing with 1. we say if consecutive 1 is not 0, and then we set it to 0, because that means we hit it again, and then we need to redo it. Actually, only these two, so this is going to be an else, right? 0, else, and they're doing the same thing, so this one can be this, and we just return rest. Basically, we're saying, so if it's equal to 0, we can say consecutive 0 equals equals consecutive 0 plus 1. I'm going to put this in the parentheses. If consecutive 0, else 1, right? Else is 1. Hold on, but it's never going to be, how do I restart the count? So like consecutive 0 is 2, and 1 is also 2, and comma 0 again, and we say, if it comes to 0 again, we're going to check the previous one. Okay, we check the previous one. That's the signal of recount. No. That's the, so if it's 0, right? And we need to have I. So I and this enumerate S, right? If the letter is 0, and then when it say if I is larger, if I minus 1 is larger than equal to 0, and I s I minus 1 is a 1, right? Then when I say consecutive 0 is 0, right? And then we do this. That's how we like reset. So we need to do the reset thing here, but this time is going to be 1, and this is going to be 0. Yeah, so that's the reset, right? We have start from 0, and then nothing happens, but here, right, it's a 0, and I minus 1 is larger than 0, and it's 1, so this is a start. So we set it to start. So we basically recount. All right, let's give it a shot. We have two test cases. First one is 0, 0, 1, 1, 0, 0, 1, 1. This one gives us 6. Second test case, we have 1, 0, 1, 0, 1, which gives us 4. And we have S. Okay, so this one is going to be count, binary substring, S. Try it. And enumerate. All right, we passed one, but we failed the first one. That's fine. Let's take a look. Why did we fail? I got 9. So okay, let's run through the first one. How do we run through? So it's 0. So every time we do this, let's print. Let's just print I want to know where they are, and consecutive 0 and a consecutive 1. So kind of see. All right, so consecutive 0 is 1. All right, that's cool. Yeah, actually, let's do rest as well, so we have an idea of how everything's going. Like, see where things kind of go wrong. Okay, so 0, 1, 2, we hit here. Now have 1, 1, right? And then that's 1, and that's a 2. Why is this 3? Oh, plus equals min. It's not min. It's not min. It's not min. It's 1 is bigger. It should be plus what? The current that is being increasing. Okay, let's see. If this plus 1, then rest gonna plus equal to consecutive 0, because consecutive 0 is increasing. So it has to be smaller or equal to consecutive 1s, right? And then this one is 1 is increasing, so it has to be consecutive 1 smaller or equal to 0. Okay? This one we pass. Yeah, so it's not a min. Yeah, it's not a min. It's whether the ones we're increasing, either the 1 or 0, whether we're increasing, we can be contained by the previous zeros or ones. So this one, they both pass. Submit it first, and then I'm gonna check. Yep, accepted. All right. Let's see if we can make this even a little bit easier. I don't know. I feel like I can combine these two together, right? Yeah, I feel like I can combine these two together. How do we combine these two together? Basically, it's the exact same thing, but just slightly change. Wow. I mean, let's just write a solution. So the idea is to count consecutive. I think I misspelled it. Consecutive zeros and ones, and each time a new 0 or 1 is counted, we can determine whether this addition can be made into a valid substring. The criterion for this is that the current consecutive zeros or ones, the number, right? The number of the current consecutive 0 ones is smaller or equal to the immediate, right? The immediately previous ones or zeros. Immediately equal to the number of the immediately previous consecutive ones or zeros. We simply add all of them together, all of the valid instances together. So this is ON because we just run it one time, and this gives us a 208 millisecond or 21% ranking. That tells us there might be a better solution. I mean, look at this, right? Seems to be there gotta be a easier way to handle it. This is a lot of repetitive here. I mean, one thing we can do, yeah, the main idea, that like I have the min, is we finish counting. Yeah, I can try that. Like we finish counting, and then we only need to call min once, right? So let's be solution 2, solution 1. So we don't do the addition so many times. So we're gonna say if it's 0, if it's the last one, the previous, and then we do this, that's when we're gonna, so that means, what does it mean? The current one, like 0, and the previous is 1, so 0 has it's restarted, right? So the previous 0 cannot be used again. So in the rest plus equal to min consecutive 1 and then consecutive 0, right? And then we don't need to do this. And here is the same, rest plus equal to min consecutive 1 consecutive 0, and then we do this. Let's see, solution 2. Oh, that is not correct. Hold on, we just missing a little bit. We seems to have to do this at the end as well. Yeah, so I have to do one more at the end. Yeah, just plus min consecutive 0. I like to do one first, consecutive 0. There we go. So this one, check, but this one, yeah, we have to check every single time. We have to check every single time. If it's not, we keep going. So let's see how long this one takes. Actually, we can go to solution and check here. So we can see the runtime immediately. Hopefully this one's faster, because I think it is fewer. No, it's not. Anyway, so this one is use update res not on each iteration, but on when we switch consecutive, we switch from 0 to 1 or 1 to 0 on consecutive switch. Yeah, I'll just do this. That's fine. All right, let's go to the solution. Let's see. It's oh yeah, it's an easy question, which means this maybe my method is not. My method doesn't feel like easy to me, man. 696. Oh, a lot of 6 and 9s. All right. Group by characters. When linear scan. Okay, let's take a look. Convert the string S to an array groups that represents the length of same character. Yeah, then we just, that'll be 2 plus the smallest, 2 plus 3 plus 4, right? So 2 plus 3 plus 4. Min, yeah, so that's the ideal of this, right? But they are doing it like going 2 times, right? They're doing it like going through 2 times. Because they first calculate the groups, and then they run the groups again to add these two together. That's fine. Linear scan. Oh, that's it. Oh. That's how you make it easier. Yes. So it is this solution. And we just say, oh yeah, we don't have to check this. Just check this is not equal to the previous. And answer equals this. We switch previous and current. Oh yeah. Wow, yep. Is this an easy question? Yeah, this doesn't feel easy to me. Easy is relative, but I solved it under 4 minutes. Other people might have taken longer, so it doesn't really matter. No, I mean, there is a, I shouldn't say a subjective way to determine whether a question is easy or medium or hard, but I think just like the number of loops you have to go through in order to solve a problem. I mean, a loop could be very easy for you to detect, right? It's like 1, 2, 3, boom, 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 you get the connections. But sometimes it's not easy to find a connection. So, I mean, the number of loops you have to jump through to solve a problem is how I consider whether a problem is easy or not. Like this one, I think you need to jump through at least 2 loops. One loop is you need to figure out how to count the consecutive zeros and ones, right? Count the groups. And the second, you need to realize we need to find the minimum of adjacent groups, right? So there are two loops to go through. I think an easy question has 1 to 2 loops to go through. A medium like 2 to maybe 3 or 4, 2 to 4, and a hard question will be 4 or above. You know what? I don't think a question really has 4 loops to jump through. It's also like how difficult for you to find a loop, right? So you know what? It's a hairy question. I shouldn't really pay too much attention to this. Not easy to understand. I mean, it's fine, but that solution is better than mine in terms of programming, not in terms of the idea. We have the same idea, which probably is the only idea, but this is a better implementation of a solution too. So I'm gonna use there as pre and current, right? Pre and consecutive, and just pre and current. And then we do have to use this. Then we just need to use I. We have to check I minus 1. Therefore, pre is always going to be 1, right? Pre is going to be 1. Current is current. So now I can say for I in range 1 to len s, right? And then what I say is if si is not equal to si minus 1, that means we have swapped, we have changed. Then rest is going to plus equal to min, pre and current, and pre and current and equal to, so the current is going to be here, and current is going to be 1, right? Else current plus equal 1. Yep, I think that is the one. And at the end, when we exit, we do have to do pre and current again. So let's try solution 3. Oh, it did not pass. Why is that? I do not know. Because I start from 1, so I start from 1. Shouldn't the pre be 0, current be 1? Yeah, I think it's pre 0, current is 1. Yeah, pre is 0, current is 1. That shall pass, yes. So the trick is to not differentiate between 0 and 1. Instead, we simply compare adjacent letters. And when they are different, we know that when they're different, we know that a change has happened. Also, we use pre and current to record the consecutive letters, consecutive zeros or ones, like zeros or ones that happen before and right now. Yeah, this is a better solution. I like this one. This one may be the fastest because it has much less things to do. Oh, look at that. Look at that. It's all ON, but this one runs at a 152 milliseconds and an 86%. That's not my solution, so don't even mention about ranking. But yeah, take a look. This one's 224. Because every time when we do a check, right, and I have to do another, I have to do this, right? I have to do this, I do this. I mean, either way, I have to go through a lot. But here, This one only goes through 1, right? It's 1. They'll have to do at least 2, right? At least 2 for each path. Here, 1 is only 1. And on the other one, on the other side, here we have to do the maximum will be 1, 2, 3, 4. 4 operations on a path for the max. Here we only have 2 operations. I mean, it's not like min is another operation, but it's like only 2 lines, right? 2 lines to go through. That's why it's like about half, right? It's actually not half, but we kind of know. All right, easy and concise with explanation. I wonder if Python has a account number 1 and 0 grouped consecutively. Second, any possible substring grouped consecutively, a number of values will be the minimum. Yeah. I wonder if Python has any. Holy moly, what is this? Prepare to be mind blown. Okay. Oh shit, it's a map. So I'm gonna replace 0, 1 with we're just adding empty space between, and we're gonna so this start replace, so that will have, and we're gonna split. So that's gonna be 0, 1, 1, 1, 1, 1, 1, 1. And then after we split, no, we are only creating gaps in the transition, right? In the transition. Then we split, we're gonna do len, and then we, oh wow, holy moly, this is smart. Or dead. Yeah, have a higher chance of you. I was gonna say dead, but that's encouraged. Are you alive? Well, that, yep, that's exactly what we're doing. We hope that LeetCode will continue to exist. No. Yeah, this is incredible. I mean, we know the solution, right? But this is just on another level. Well, the solution that adds gaps between transition of 0 and 1 is on a different level. Whole nother level. Let's make it as whole on a whole other level. Brilliant. Yeah, there's nothing you can say. It is brilliant. Yeah, exactly. This is wow. I mean, I want to do this. I want to do this. Oh, I need to credit. I don't want to look at his solution while doing it, but I want to credit. I saw an O1. What the hell is a space O1? Ah, O in time O1 space. Oh, that's fine. All right, so I'm gonna do another one. Class solution 4. Count binary substrings self str turn an int. All right, I'm gonna say from Lee 3 to 15. Amazingly smart solution. All right, so when I say gapped equals s dot replace, right? 0, 1. Man, this is just so smart. 0, 1, and we can chain it. 1, 0. That's a transition. 1, 0, right? And then we're going to split it. So we're going to say group consecutive length, right, equals gap.split, right? After we split, we're going to say len len g for g in this, right? Thus we get this, and finally the result is going to be consecutive. So we're going to zip, right? So we're going to say sum, return sum for say L1, L2 in zip consecutive length and a consecutive length 1, right? So we zip it and min L1, L2, 4. And then there's going to be solution 4. Marvelous, just marvelous. It's the same idea, but by adding gaps between transitions of 0 and 1, the implementation is vastly I should say mentioned is vastly simplified. I mean, I shouldn't say simplified. It's just shorter, much shorter. But let's see, how long will this one work? I'm really hungry right now. My stomach just made a noise. I don't think it's gonna be any faster, but holy moly! I took it back. I said it's not gonna be any faster. What the hell? What the hell? Because all of these are built in. You are not doing any loops. That's why. Like this is built in. This is built in. Like when we have one loop, but this is like we still have loops. But this built in, I guess, is be very fast. And then this, I don't know. I mean, this is just wow. Kudos to him. Very magical. Very magical. See, even if a question is simple and we solved it already, it's always good to go back. Oh, that's Ruby. I was like, I don't understand anything. Find all. Ah, yes. Can use find all. We can use find all zeros and all ones. That's true. I don't have to pair them myself afterwards. Oh, they pair it for you. I don't even understand. I don't want to go into this. I want to respond. Just chill. Just chill. Just chill. I mean, but this is at the beginning, so people don't know it. He probably hasn't had this much, but I'm not gonna engage in this. But it's amazing. I mean, I understand this. This I want to say I understand. Find all. And what is this? This isn't this the look ahead? Not look ahead, but look behind. No, this is look ahead. So we look ahead. Huh? Why did it become pair? I map the pair. Yeah. And then you pair. But you don't select it. That just means all zeros or anything. like 1, 1, 1, or no ones. And then we say find all. Find all just gives us all of these, right? So this just means we're going to find this, and I don't understand. And I don't want to understand. I mean, these regex, it takes too much of my energy right now. All right. Hit my point. I mean, I don't want to understand myself, but I can always find helper. What should I say? This is like my obsession. Right? I have this type of obsession that just I cannot help. Okay, so 1 1 0 0 1 1 0 0 0 1 1 0 0. Okay, so first capture group. Second alternative, positive look ahead. Yes, assert that the regions below matches. Match this. Yeah, it is a look ahead, and it's a greedy look ahead. 0 or unlimited. And what does it return? I mean, if I don't use this, I'm going to have the same thing. But if I use this, I think it has something to do with find all, right? Like, if I don't use this, I think what this one gets is just, why don't you try, right? You're speculating right here, have nothing else to do, right? Just try it. S equals, let's just do 1 1 0 0 0 0 0 1 0 1 0, something like that, okay? And then we say read off find all, 0 plus and 1 plus, right? And S. Yeah, that's what I expect. But what if I adding, oh, now we have groups, okay? That's the first group. And we have a positive look ahead. Okay, what does this one give us? Wait, what? I think I forgot a parentheses. Holy moly, it can do it for you. That it has something to do with Python regex. I have visited the regex for many times. Let's find all. Okay. All non-overlapping matches of pattern, okay, as a list of strings. String is scanned left to right and matches are returned in found order. If one or more groups are present in the pattern, return a list of groups. This will be a list of tuples if the pattern has more than one group. So I have two groups. So in the return, there will be two groups. If one or more groups are present, return a list of groups. A list of groups. Ah, I understand. But why is this? Because you want the last one. Why do you want the last one? It doesn't make any sense. Like, why don't you just use this as well? Right? So 1 1 0, 0 0 1 1, 1 1 0 0 0, 0 0 1, 1 0, 0 1, and 1 0. Yeah, why do you use the star? Maybe if I change into this. Wait, what do we have? Do we have requirements? It contains both. No, no, it shall be able to handle like all ones, right? Shall 2. It shall be able to handle this. That's a 0. But here we are not. But if we say this, that's why. That's why. It's this. Very smart. Very, very smart. I want to write a comment here. Amazing solution. For those complaining about readability, please chill first and then try to appreciate the brilliance in it. Try to appreciate the brilliance in it. Of course, we will not code like this in interviews, but the amount of knowledge in this, hidden in this, in the one-liner, in the Python one-liner deserves further exploration. The trick with 0 plus and a 1 plus, the trick with regex pattern is self-explanatory. However, the trick with this actually is read.find all. This, but the trick with involves, contains 2, 3, contains 3, contains 3 aspects, right? First, the positive look ahead makes it so that, well, actually it's positive look ahead, but it's still grabbed by the find all. Find all grab positive look ahead. I mean, positive look ahead means we'll match, but we just don't consume. I think that's the trick, right? Positive, yeah, look ahead. It says it'll match, right? But it does not consume. If I can find the text for this. The current position called positive look behind. Let's find a match. Positive look ahead. Where's look ahead? Here's look ahead. So look ahead, but doesn't consume. Yes, that's the thing. Can we quote this? I have to find a section, regular expression. Yeah, okay, do this. Where is the comment? The positive look ahead, which is this part, 0 plus and 1 star, right? The positive look ahead makes it so that we match a group of 0 or 1, but we do not consume it. See, dark, right? But we do not consume it. This way, we can match groups in pairs. We can match groups of 0 or 1 in pairs, in consecutive pairs. 2, the find all, the read of find all returns a list of tuple if groups are involved in the pattern. This is why we can produce a pair after mandating in the pattern that we are. This is why we can produce pair of groups after using a pair of if groups are using a pattern. Yeah, that should be enough. 3, the brilliant use of 1 star instead of 1 plus toward in the end, because yeah, in the regex pattern, the brilliance of this is because this is to handle. This is to handle the edge case, because we try to match 1 because it's greedy. Yeah, it wants to match. It wants to look ahead. This is to handle edge cases. Actually, it's actually more than edge case. Even in this, yeah, I think it's anything to handle cases where the last group contains more than 1 0 or 1. For instance, 1 1 1 1. Right. For instance, actually, well, let's just do this. If the string is 1 1 1 1, a match to the pattern, this produces this. I cannot select, that's fine. Produces a couple 1 1 1 and 1. Because the look ahead always want to match at least, right, at least one. But what if it's 0? Like, what if it's 0, 0, 0, 0? Oh, it's or. It's or, because the lookahead always want to match at least one letter. Produces this, which is wrong. This happens because the lookahead always want to match at least one letter, whereas we do not. We do not want at least one letter. Using this pattern, we will get one, 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 and an empty string, which is what we want. I shouldn't say this. Allow me to add some context. To allow me to expand. Allow me to explain in case someone is confused. Okay, let's see if it looks good. The trick with this is self-explanatory. However, the trick with this contains three aspects. First, positive look ahead, which is this part, which is, I don't know if I can say this part, which that is positive look ahead, that is, makes it so that we match a group of 0, 1 without consuming it. Right? Match a group of 0, 1 without consuming it. Without consuming it. This way we can match group of 1, 0 in consecutive pairs. Without consecutive, this way we can match, this way, say we are matching 0, 0, 1, 1, 0, 0. We can match, we can match 0, 0 and 1, 1 in our first attempt without consuming 1, 1. Thus, when we move to 1, 1, we can match 1, 1 and 0, 0, 0, 0 again. Okay? Example is the most important. This way, say we are matching this, we can match 0, 0, 1, 1 in our first attempt without consuming 1, 1. Thus, when we move to 1, 1, we can match this again. The read-find all returns a list of tuple if groups are involved in the pattern. The brilliance of use this instead of this. This is to handle cases where the last group contains more than 1, 0, or 1. For instance, if the string is this, a match the pattern with a plus produces this, which is wrong. This happens because the lookahead always wants to match at least one letter. Using this pattern, we will get, which is what we want. Yep, let's post this. It's a good solution. I mean, it's a good solution. I'm happy that my obsession to, I just don't want to give up, right? My obsession helps me understand this. It's always good to see some look ahead or look behind in the wild. Help me understand the brilliance of this. I still remember the first time when I stumbled upon the look ahead and look behind. That's when I was trying to solve, what's the problem? I remember it was I was doing AWS CLI, and I got some return values, right? And I want to create some script so I can automatically spin up some Lambda functions. But when you do that, they require you to obtain like the ARN, or the versioning numbers, or whatever ID numbers. I mean, in the output of CLI command, you can see the function. You can see your function's name, you can see your version and whatnot. And I can use grep, right, very easily to obtain the line that contains the target we want. But the problem is when I grep it, right? If I say I want to say version equals something, I wanted the something, right? But I don't want versions. That letter versions we don't want. But I cannot, because the identifier is the word version, but the content I actually want is the number. So I got stuck. And then I think just randomly searching online to scratch my head out, and I find out that in regex, there's this thing of look ahead and look behind where they match but do not consume. So I can do a look behind to match version, right? And then to actually grab the value itself. So the version will not be matched, but it will not be grabbed, but it will be matched. So that's my first exposure to look behind, look ahead. And ever since then, every time I see look behind, look ahead, I got a little bit overexcited, really want to understand. It's good. I mean, it's really good. I respect him a lot. And LeetCode 15, they're just the pinnacles of solving these type of problems. I hope one day, if I keep practicing and eventually I can turn into not mediocre. I mean, I don't see myself approaching this level, but probably I will be able to, be smart enough to think about the existence of this type of solution. It'll be nice to do it that way. Anyway, enough rambling. An easy question and it lasted for an hour, but I think it's good practice overall. So I'll be it for today. See you guys tomorrow. Probably a hard one. Adios.